Hey there, guys. I'm starting this a bit earlier today because I had the impression that some people join and they see that it still didn't start and they go away for a bit, and when they come back, they already lost something. So now I'm starting it just a bit before so that people who are already here can join. Oh, if you're there and you wanna interact in the chat, please do, because it's super nice to know where you're from and what you're doing right now. Uh, and I usually start with something which is I want to show you. First, I want to present myself, right? So, unfortunately, I don't get to meet all of you, but at least I can show you the context of this project, right? So, the project is called. First, let me introduce myself. My name is Leonardo Bezerra. I'm a professor here at Universidade Federal do Rio Grande do Norte, UFRN. It's a city in Natal, in Brazil. Usually, when it's people who are not from here, they don't really know where. I mean, they know where Brazil is, but they don't have any clue on Brazilian geography. So sometimes it helps that I show where we're broadcasting from, and this is where we're broadcasting from. So maybe it's difficult to see it from here. Let's zoom out a bit. So everybody was asking me, so is it close to São Paulo or Rio de Janeiro? So these are São Paulo and Rio de Janeiro. This is Natal, and we're broadcasting from here, okay? I had a deal with the people that I work with in Belgium that I don't show pictures of Natal. So if you want to Google it, you're going to see a lot of Christmas picture because it actually means Christmas. But if you find the pictures, you're welcome to visit the town, okay? Well, I'm a professor here for a while, and I've been focusing on two main streams. So the first one is computational thinking, problem solving, and programming languages. And I've set up a few repositories. Most of them I created myself. Some of them were created in a collaboration with students. I proposed the idea, and the students created them, and I helped host them. So I created Python 0 and computational thinking. Right now these two are in Portuguese, they will be translated to English soon. And Python TAD is the acronym in Portuguese for abstract data types. So they're all in terms of learning Python and learning how to solve problems. Specifically, I like to work a lot of lead code and show some exercises on this topic that people can go and get ready for when you go for a major interview, and you want to get ready for that, you understand the basics. For me, it was very strange when I first went to interview in a big company and I had no clue on how it worked. So I'd like to prepare my students to know it beforehand since the beginning of the university graduation and stuff. And then the second stream of projects is for data science and machine learning, which is where this project here, this broadcast fits. So there is one repository called Data Science 0, which is basically Medium posts. Most of the posts are in Portuguese, but my posts are in English. And I'll show one of them here, just for you to see. And we're going to be translating this to English real soon. The thing is that here it's better to start with things in Portuguese, especially because Brazil doesn't have as much material as we would like Brazil to have. So I'm going to show you one post here. All my posts on Medium are in English, so if you find me on Medium, you can see these posts. And the one I would like to highlight is this. It's called the data science process. So this is from Professors Joe Blitzstein and Hans-Peter Pfizer for the Harvard Data Science course. And I really like this chart, this graph, because it illustrates very well what's the idea behind data science. And this is very important if you're trying to do machine learning, right? You have to understand what part of the pipeline you are at. So the data science process starts with questions, with relevant questions, where these questions have to be answered through data. So you have to know if you can find data that will help you answer that question and how you can work with that data. Once you get access to that data, you can start exploring and understanding the patterns and the insights that the data can provide, and then you can see if the questions you're trying to answer will be if it's feasible to answer them. Uh, and then comes the part where we are at here, which is modeling the data, which basically means that you're gonna try to predict something from the data or find patterns in the data that you could use to segment your audience, for instance, or find profiles in the data. And then there's the whole part of data visualization, data storytelling. So how do you communicate, how do you visualize the results, right? So this is the data science process workflow, and we are just one box in this, right? So every time I'm showing you some data sets, I would like to start from the beginning and what kind of questions we can answer with this data set and go all the way to visualizing results, but that's not feasible in the time frame we have. So what I'm gonna do is that we're gonna focus here, although I will show you how to get the data and how to explore it a bit, very briefly. So there's another repository called, so the repository we're gonna use today is called scikit-0, so it's scikit-learn for non-programmers. So you might be thinking, how are you saying that it's machine learning for non-programmers if it's based on Python? So the idea is that I've taught this course using Orange 3, which is a great tool that doesn't depend on programming and people learn a lot. But all of the people I've taught this course to were eager to learn how to do more, how to go deeper. And going deeper means using tools like scikit-learn, right? So that's why right now I'm focusing a bit on this because they're called Pandas 0 and scikit-0. Pandas is for data science, so if you know the Pandas library, it's basically probably the most used data science library in the Python community, which probably is the largest data science community in the world if you're talking about programming languages. And in parallel, scikit-learn is probably the most used machine learning library there, right? So basically my goal here, and a lot of students have put an effort to help in this goal, is that you can get to learn Pandas and scikit-learn without knowing how to program. So let me give you a brief introduction in this, okay? So, well, Pandas is available in Portuguese and English, Pandas 0, and scikit-0 is available initially in English. So the idea is kind of summarized here, right? So you could use graphical user interface software like Orange 3, Weka, and other tools, and you find very nice tools around to use and to start doing data science and machine learning. But when you want to go deeper, you're going to have to use command line interface tools, okay? Command line interface software. And the idea is that you're not actually programming in the sense that you don't need to have the background on programming logic and computational thinking, but you need to understand how to write code, right? So the instructions you're going to give to the software that you're using are going to be given using a programming language. So it's different from programming, but still requires that you understand the basics on a programming language. So what I do here is that I abstract all of the things that could be complicated for you to understand if you don't know how to program. So for the guys who code, there are no ifs and no fors. There's really no loops, decisions, none of that, no procedures. I don't ask you to prepare any of that or to understand any of that. The only thing I need you to understand is that if you're taking this course on scikit-learn, you have to understand pandas. And then there is Pandas 0 for that, okay? So on Tuesdays and Thursdays at this time, I'm running these broadcasts, and on Tuesdays I'm focusing on pandas, on Thursdays I'm focusing on scikit-learn, and if I show you the YouTube channel, so my YouTube channel, which is where you are since you're watching this live, you're gonna see there is a video, so First Steps with Pandas, that was published yesterday, which was from the broadcast that I made on Tuesday. So if you're starting to learn Pandas, start here and check Pandas 0. If you're starting to learn machine learning, then we have these tutorials on, let me show you here at the beginning. So the first one would be the first steps. I already had this last week, although I don't have the English version here. So this is something I'll have to do again, but the collab is available if you want to check. And today we're going to have data preparation. So I already uploaded 2 notebooks, so for today and for next week. So you're welcome to watch this one today and to go back to first steps, go back to Panda Zero, so that you can get in up to date. So you can go for the transformations one, which is going to be a bit heavier. So this one is very simple. This one is also very simple. Colab, if you never heard of that, is an interactive environment where you can run code and you can have the idea of an HTML page, like a web page. So basically when you see here, you have things that you can write. So you're annotating something, in this case the description. For me, I write this as a tutorial, and I have code cells that I can run. Okay, so the code cells I'm gonna run are based on Python, and I'm connecting here to a computer in Google's infrastructure. Okay, so this is provided by Google. It's gonna run in a Google machine. The thing is that at Google, you're not gonna have a whole computer for yourself. You're gonna be sharing the computer with many people. The way that they do it, so you get security in that your data is not shared to others and people, and you don't have access to other people's data, is that your code is gonna run in a container. A container is like a computer, but miniaturized, right? So every computer can simulate many containers, can host many containers. So you're safe to run your code and not be concerned about security issues. I mean, at least as what it concerns other people running your collabs, okay? So the first thing here is that we're gonna be talking about outliers and data imputation. So outliers are data samples that are so different from the remaining samples that you have that they're gonna completely skew your analysis. And I learned this the hard way. I was taking a PhD in optimization and I was using some metrics that I had to deal with. And because I didn't care for outliers in the beginning, I had these results that made no sense because they were completely skewed, right? So outliers are something that you should try to identify straight from the beginning and remove if you can, or you can isolate the outliers and say, so, okay, I'm going to do a separate analysis on the outliers if you're ever interested in the outliers, and that could be a case, okay? So the other thing is missing values. So missing values are values that for some reason were not provided with the data set. So when you were collecting the data wasn't given to you, right? So in principle that could happen for some reasons, and some reasons that are actually valid. So you have one answer that depends on the other, and depending on what you answered in the first question, on the second question it doesn't make sense that you answer it. So for instance, how many kids do you have? You say 0, and then the next question is how old is your older kid? You're not going to answer that, right? So this happens, but it also happens that the data just got lost, right? Sometimes you have a lot of missing data. And the thing is that the estimators that we use here in scikit-learn, so in the first collab I was talking about a machine learning pipeline. So here I was saying that we have a data science pipeline, and inside you have machine learning modeling, right? So this box is another pipeline in itself, right? So if I can show you very quickly here, the idea is that, let me switch this to Panda Zero. And the idea is that in the first link, the first collab, I was showing the idea of pipelines. Sorry. I went back to Panda Zero, sorry. Scikit Zero. Yeah, this is correct. So Scikit Zero, you go to first steps here. And the first collab was on understanding that any machine learning thing that you do, any machine learning process that you do, will be a pipeline. And in a pipeline, you have 3 elements, which are summarized here: data preparation, feature engineering, and estimators. So data preparations are we're gonna deal with this now, and estimators are the algorithms that in the end will do the prediction that you need them to do, the modeling that you need them to do. So we're gonna start with the idea that estimators need data that has been prepared, right? So that's what we're doing here. This is the first stage. So let's see, we're talking about outliers, and let's see this in practice. So let's download a data set from Kaggle. Kaggle is a great website where you can see many data sets available. So if you Google Kaggle and NYC Airbnb, Google search, you're gonna find the open data for Airbnb listings from New York City, right? So there's a whole data set here that you can check. You can see some information on the data. You can visualize the data set and its features. Here, what we're gonna do is that we're gonna use these as we're gonna use this to do the analysis. So in another collab, I had already taught this. So the idea was first I'm gonna import the libraries that we're gonna need. So the first time you run something that Google didn't author, they're gonna say, okay, are you sure? Yep, I'm sure. So since we're downloading from Kaggle, there are two ways you can do it. You can go here. Sorry. Let me go. So you can go here, click on download, and then you log in and you upload this data set to the Colab, right? Or you can do what I'm gonna do. What I'm gonna upload is basically just the credentials. So there's a tutorial teaching how to do that. So kaggle.json. So it's telling me that when the runtime is recycled, I'm gonna lose that file. So just to explain this, containers are what we call volatile, right? So they are gonna be recycled, they're gonna be thrown away after you reach a maximum runtime limit or after you get to a point of no interaction for a given time span, right? So whatever you upload here is gonna get recycled, it's gonna go thrown away, right? There's an option that you can mount Google Drive here to use it, and in a different, in Panda Zero I teach all, we have tutorials that teach all these kind of things. Here I'm going for the simple. So there are some cells here, these 3 cells that I don't expect, especially these 2 here. I don't expect you to understand them, but you should know that you need to do this if you're going to download from Kaggle. And this is actually easier to see. It's just Kaggle datasets download. Anything that starts with an exclamation point is not Python. It's what we call shell script. So these are Unix commands that are being run at Google's computer, right? So the container you get access to is a Google computer, and it runs Linux. And this is the Linux way of saying unzip this file, please. Okay. So these cells are something you need to abstract because I'm showing you how to do it from here. And if this is the first tutorial you're seeing, you're probably a bit lost. But if you go back to the tutorials on Panda Zero, you're gonna see that we've done that. We've tried several different ways of mounting the drive and accessing your Google Drive, or uploading the files, or downloading. If it's not from Kaggle, you can read it directly from the URL, depending on where it is. Anyway, we've downloaded the dataset, and now we're gonna read it. Okay, so if I skip the basic things on pandas because I'm assuming that you've taken the Panda Zero course. If you haven't, you're going to see that you need it, and you can go there and study the collabs, okay? So head gives me the 5 first samples, and I can see all the features here. Let's see how many samples, what's the shape of the data. There are almost 50,000 samples and 16 features, okay? So each of these features have types. It's easier if you, since we have Kaggle here, it's easier if you do like this. So here you can see the feature names and what they're supposed to mean. Here you have a description, a summary of what they are, right? So you can go back here and check it when you want it. Here I'm gonna summarize the most important parts. So the first thing is there are many more samples than we were using in the first tutorial on scikit-learn, which was the iris dataset, which was like 150 samples and 4 features. Here we have 50,000 samples and 16 features. 50,000 samples is quite reasonable, okay? Many datasets you'll get will be around that if you're not talking about big data. 16 features is not so much, right? So, but it's gonna help us here. So even if it's just 16 features, I'm gonna do something here. I'm gonna discard 2 of them. ID was basically the listing ID. It's just a computer thing to say that every listing will have a unique identifier, and that really doesn't help us do any kind of prediction of segmenting, so it's not going to help us there. And last review is the last time there was a review to that listing, right? And that could be interesting if we were doing time series analysis, but here in this one, that's not the point. So I'm going to discard them. I'm gonna drop these features. Now we're gonna have only 14 features left. Okay, I didn't give it here, but if you want to add a code cell, I'll even copy here to show you. And it is that now you have, okay, sorry, I called the dropped data frame, the reduced data frame X. So this is a convention in scikit-learn. I don't like names that are just a single letter, but I'm respecting the convention that the input data should be X. And if you have something you want to predict, it should be Y. Okay. Well, before we go on to the specific topics, I've discussed before on Panda 0 and scikit-0 how we can do something on missing values. And we see the missing values like this. For instance, for each of these features, for name, we have 16 missing values. For host name, we have 21 missing values. And for reviews per month, we have almost 25%, actually almost 20% of missing values, right? So for name and host name, this information is there's so few samples that are missing values for those features that I'm gonna say, okay, let's drop this. I'm gonna drop those samples. And of course, I'm gonna hope they're not super important to the analysis. They could be, but here it's gonna be reasonable, okay? And now when you check again, so the samples that had these, some of them were also related to reviews per month, so they also reduced the number of reviews per month samples that have missing features. But anyway, we still have many reviews per month values missing. Just to confirm the shape, now we still have almost 50,000 samples, but we discarded those, like those from before. We had 48,895, now we have 48,858. Okay, so let's move on to the idea of detecting outliers. So the first thing you try to do is, if you're going to do a lot of transformation and a lot of prediction of the data, you have to make sure that your data makes sense. And outliers are, like say, an exception to those patterns. You're trying to find patterns, and then you have these outliers which break the patterns. So they don't help you. They will make your life much more difficult. So when you're trying to find outliers, generally they will come from numerical features. This is not necessarily true, but it's a good guess for us here. And I've selected all the numerical features from the dataset except for latitude and longitude, and I can show you why. Because I checked here, and latitude and longitude, the distribution is not very strange, right? Maybe longitude has this long tail here on this side, but I don't think it's enough to make it a big problem. You could have added this again. You can run this adding longitude and see if it changes, and probably it will, but what really matters is that in the end of the pipeline, the results you get are better. So it's difficult to make that call right now. So this is the kind of things that show that building a machine learned pipeline is very complex, right? So that's why there are AutoML alternatives and all these kind of things. So when I check the distributions for these data here, for these features, they all follow a exponential pattern, right? So there's a big bar here, and the rest are very, very low that I probably can't even see, right? So it happens even for last review, but last review dropped. So all the other ones, availability is a bit strange. It's not exactly like that, but still, I think it makes sense to have it treat it as if it were an exponential distribution, right? An exponential distribution, if you've been through Panda zeros, you know it's a long tail distribution, so the tail is here. And in general, when you sum up all of these values, they still don't make up for these values here. So it's a completely asymmetric distribution. Well, let's go on. Since we're talking about the exponential distributions, we've discussed this in Panda 0. What we can do is that we can apply a logarithm transformation to say that now, instead of talking about the original values, we're going to talk about them in a log scale. So I apply this log1p function method here, which basically calculates the log of 1 plus x. So we usually say 1 plus x because if you have x equals 0, that would be an infinite number. So we want to avoid that. And adding one won't be a problem because we're adding one to everybody. So now let me show how price was before. Price was like this, and now price looks like this, because now we're talking about the log scale. Okay, so it's not a normally distributed data, but it's much more close to a normal distribution than it was before, right? And in general, we want to stick to normal distributions when we can. So what we're going to use here is a clustering algorithm. So the idea is that it's going to try to build a huge cluster and see who doesn't fall into that place. So let me see if I can find the example here. So the class is this if you need to go to the API, but probably would need to learn to know a bit about computer science, which is not what we're trying to do here. So just to show, the idea is that okay, let me go to the user guide and look for outlier, and you'll find, okay, outlier. So novelty and outlier detection. And here is basically what it's trying to do, right? So this is local outlier factor. It's trying to find clusters that make sense, and the blue points are the points that do not make sense, right? So they don't fit the clusters that you can find. So these would be the outliers. Of course, there can be many, like you saw there, or less, not so many. Well, let's try. Let's see what we get. So what I'm going to do here is that I'm going to start isolating the numerical features so we can run this. But I'm going to keep the index preserved so that when you want to bring the data back to the original data frame, you can do it, right? So let me, one thing that is interesting is that the model will be built like for ones or minus ones. So ones will be the inliers and minus one will be the outliers. In here, one are the orange dots and blue, minus ones are the blue dots, right? So all those blue dots will be considered outliers. So I've predicted this. Notice that I'm using fit predict directly, and that's generally one thing you do with these classes for outlier detection. And we can concatenate back what we had. So we had xnum, which were just the numerical features that if you want to see it here, so x.head, sorry, xnum dot head. So we selected just the features we were talking about. Now we applied this, we fitted this model, and the result of the model we wrapped in a series, which we call predicted, and we try to preserve the indices from the how they were in xnum. So the indices are these numbers here, and we try to preserve them. So if ever we want to bring this data back into X, we can do it. And here I'm concatenating on the column axis, which means that I'm adding the result from this classifier, from this algorithm here, local outlier factor. I'm adding this as a new column called predicted. So basically what will happen is that if the sample was considered an inlier, this column value will be 1. And if it was predicted an outlier, this column value will be predicted -1. Okay? So if I want to just get the outliers, I carry for predicted equals -1, and that's what I get. So in principle, in the beginning, I was forgetting that I was using head here, and I was like, oh, only 5 outliers. That's nice, but that's not really true. Actually, you have like 1,700 outliers according to this algorithm. It could be another algorithm. It could come to a different conclusion. But here I'm just showing an example of how you can do this. So everything that you learn about machine learning should bring you closer to the perception that machine learning is not for humans. In the sense that yes, very specialized people with a lot of experience and a lot of white hair will be able to look at the data and say, oh, we should use this, this, and that should give me good results. But in general, in principle, machine learning is something where we understand the steps, we understand the possibilities, and we need some kind of heuristic guidance to make the choices for us. Okay, that's where RML and other alternatives come in. Well, since we have preserved the index, we can now say, okay, I'm gonna drop all the samples in X that match these indices from this carry, right? So all the samples in X predicted that were defined as being outliers. By the way, I didn't notice this. I could just have done this, okay, to make it simpler. So all these outliers will go there, okay? And then I can drop it. And when I do shape, that should give me, yeah, around 47K, right? Originally we had around 48,800, and here we have 47,100. So we're removing 1,700. That makes a lot of sense, right? So I've deleted all these outliers here. In principle, if you're doing that in a real world project where you have a lot of time, you wouldn't go so fast. You would start considering, okay, are these outliers really outliers? Could I have tried in other models? Could I have tried other approaches? And this is something that you should understand. Here in scikit-0, as well as in panda-0, I could have chosen to say we're choosing a single data set, we're sticking to that for life, and everything we do is going to be on that data set. And then we would be able to mature a lot our understanding of a single data set. That is a possibility, but that's not the path we took here. The path we took here was that I want to give you the opportunity to meet as many data sets as possible. And this was actually something that I didn't plan for. The students who built up these collabs each were finding different data sets that they found interesting and they wanted to use them. And I'm just saying, awesome. That's why I reuse a lot from the data sets that the students have found, or eventually I come up with a new one like this one. So that's why you have many data sets, and the collab, each collab doesn't have the purpose of saying it's perfect, now it's done, you have nothing else to learn from this data set, okay? So just seeing here, I have all the data, the original data, except the outliers, and I still have the missing data here in reviews per month, right? So before I move on to the imputing missing values, I want to give you like 1 or 2 minutes if you want to say something on the chat, like if you want to ask something, if you want to comment something. It would be really interesting if you could say where you're from, how did you get to how did you hear about this broadcast? And there's a delay that is about 15 to 20 seconds between what I say and when you actually hear it. So I have to wait a bit for you to give me this feedback. So I'm gonna give you like the time to hear what I'm saying, and then a bit more time to type something, and then I can reply. If you don't reply anything, if you don't provide any feedback, I'll move on to this imputation part, okay? So I'll just wait a bit. There's a delay that is about 15 to 20 seconds between what I say and when you actually hear it. So I have to wait a bit for you to give me this feedback. So I'm gonna give you the time to hear what I'm saying, and then a bit more time to type something, and then I can reply. If you don't reply anything, if you don't provide any feedback, I'll move on to this imputation part, okay? So I'll just wait. Okay, so no feedback, let's move on. By the way, if you want to write something, if you want to provide feedback, don't worry, you provide it. I'll be moving on with the topics, but when I see that there's feedback, I switch back and we interact, okay? Well, and also don't mind just because this talk is in English, right? So, in the world, out there in the world, everybody communicates, and it's not the language that will be a barrier. In the sense that don't worry if your English will be perfect, grammarly perfect or not. In general, I mean, I'm Brazilian. My Brazilian Portuguese grammar is not perfect, even if I've studied so much. So it's normal. We just have to communicate. Well, so let's talk about imputing missing values. It is that missing values, we already discussed this, right? So missing values, let me keep the topics here on the side. Missing values can compromise the ability of an estimator. So especially here in scikit-learn, the estimators are expecting that the data is complete. It can handle missing data in some situations, but if you can impute the data, that's better, right? So if only a few samples present missing values for a given feature, we've seen that, the samples can be discarded, right? The other situation is that almost all samples present missing values for a given feature, so the feature could be discarded. So this already happened in Panda 0, and it's gonna happen in the next collab, in the broadcast from next week. But like the situation that we have here, 20% of the data has missing values for that feature. If I discard them, I lose 20% of the data. If I discard the whole feature, I lose the other 80% of the information that that feature could provide, right? So let's try imputation, which is basically producing artificial values based on the data that is available. And the types vary depending on how much of data you're going to use. So if you're only considering that given data, that given feature, sorry, the simple imputation approach will be to fill the values based, fill the missing values with descriptive statistics from that feature, right? So you could use any kind of central measure like mean, median, mode. So here by default, scikit-learn will provide you with simple imputer, which uses by default the mean. So if I create an imputer here, and since I want to apply it to just one column, I'm going to use this make column transformer method. And what it does is that it takes one or more tuples, and a tuple is defined as what is in parentheses, where we have the imputer that I'm going to use, and the list of the features to which I want to apply them. In this case, I only want to apply it to reviews per month. And I have to say something about the other features because I'm going to apply it to X, right? So what I'm going to do here is that I'm saying, okay, drop all the other features, because anyway it's going to produce a new data frame, and I only want to discuss this one. And since I'm going to do this, I have to be careful that when I apply the transformation, and here we don't use fit predict because we're talking about preprocessing, we're going to use fit transform. There's nothing to predict, right? Only to transform. I'll be careful to say, please get this result, wrap it in a data frame, remember, set the name of the column to reviews per month, and preserve the index because I'll need this index later, okay? So when I see it here, reviews per month, all the values from the series, and the index is preserved, right? You might be wondering why I'm not letting it build an index of its own. The thing is that we've been dropping samples. So when it creates something like this, pandas or scikit-learn or whatever library you're using, it would create an index from 0 to the number of elements minus 1. And this doesn't match the index from X, because you have to be careful with this, that you preserve the index if you're doing it this way. So now, if I take X mean, which is the imputed data set using the mean, there are no more null values, right? And now I want to compare the distribution from before imputing, so this is X, with after imputing. And you see that imputing made a difference, right? So something changed in that the distribution doesn't look the same anymore. And in principle, you would like that the imputation you do doesn't affect the distribution. So you could try, this is the same code from before, but I'm going to use the mode, that is the most frequent value, to see what happens if I do this. When I plot it, well, plotting for the mode is, imputing using the mode leads to a distribution plot that is very similar to this one up here. So they are not matching very much the original one. And this is one limitation of the simple imputer. Sometimes it makes sense, especially for categorical or ordinal features, to use this, but for numerical values it's very difficult. It would make sense if you had a normally distributed data, normally distributed feature, where you can just say, okay, take the mean, and that's not going to affect so much my data, because I'm just reusing the mean. But when you have distributions that are a bit different, you start making some difference there, right? So what you could do alternatively is that you could base your imputing on multiple features. Preferably would like to do that with the whole data set, right? So now I'm trying to see which samples are similar to the ones that I have, and I'll see from the feature values on those samples what should likely be the feature value for this sample. And I'm talking here about the feature that is missing, right? So One of the options is KNN imputer. So in the previous collab on scikit-learn, we were talking about KNN. So it's the same idea. You take one sample, you look at the closest neighbors if you consider that you're talking about Euclidean space. So because of that, since we're using KNN imputer, and don't want to go into the specifics of how we would apply this to categorical features, I'm going to discuss just the numerical version. So I'm only going to consider the numerical features here, okay? And what I'm going to do, so again, I'm isolating xnum here. And I did it again because I added reviews per month, right? Because I wanted to consider that these will be predicted from the others, right? In a sense, that's what we're doing here. So we're internally converting this into a prediction problem where we're going to take these features as input and these as output, right? Just to be correct, even reviews per month will be used as, it will be used as label. We're going to separate between the examples where we already know the values, so they're like the training set, and the values for which we don't know the value, they will be the testing set. But this is all done internally. We don't get to see any of that. What we get to see is that, so this is the same structure from before. I want to preserve the columns, I want to preserve the index, and I want to transform the data using KNN imputer. And this is going to take a while. It will take like 20 to 30 seconds because it's fitting a KNN model to your data, right? So it takes a bit, but when it comes out, we're going to see that it pays off. One thing that I didn't do here in this notebook, in this collab, was discussing how we can, that it takes about 40, let's say 10 to 15 minutes when I'm starting the presentation or ending the presentation. So the explanations I made in the beginning about the available repositories, you can always skip that part. It's like Netflix skip intro. And in the end, where I'm saying, okay, we're doing this and this is the wrapping up. 30 minutes to 35 minutes where I'm actually explaining the collab, and 10 minutes to interact. So here, for instance, we're not interacting a lot or at all. And because of that, of course, the time is moving a bit faster, right? But still, you're going to see that the topics we've covered here allow you to understand the context for this. And scikit-learn is extremely rich, and the literature on the internet and machine learning is also extremely rich. So use this as a first step into this, okay? So we have a question. Wait. So the criteria to choose whether to use the mode, the median, or the mean to input data is to observe the impact of the imputation on the final distribution. Being very pragmatic, no. The criteria is that you look at the end of your pipeline and you see what you were trying to predict, and you get to see if that improved the metric you were trying to improve. But a good hint that imputation is doing its job properly is that it's not messing with the distribution, right? So everything that we say in heuristic optimization or heuristic topics like machine learning, so this is our whole area of artificial intelligence and computational intelligence called soft computing. They are heuristic, which means that they are not promising you to get the optimal results. They're promising that they have the shot at getting good results. So what we do is that we understand the possibilities, but we cannot accept you're extremely experienced in the data set you're talking about and machine learning in general, or at least in the meta aspects of the data set you're talking about. You're not going to look and say, okay, I do this and it's perfect, right? That is my experience. I've been working on this for like 10 years. I took my PhD on this. It was not in machine learning, but it was in heuristic optimization, which is a very similar field. And you don't just look and say, okay, this is a very clear-cut pattern here and we're safe. So what you do is this. You try some things to understand the data and to see what you're doing and to evaluate what you're doing. But in the end, what really matters is the final accuracy. So I'll give you an example. Everybody indicates that you should use feature extraction for computer vision problems. We have a paper on AutoML where you give it to an automatic configuration tool the possibility of using selection or extraction, and it actually chooses selection. So that's what I'm saying. Sometimes you have these preconceived ideas that people have perpetuated, but eventually you can show a way that you get better results using different approaches. Okay, so that's a general hint. Well, the KNN, I hope I answered the question, right? So the final output of KNN imputer is here, right? So if I check it here, there should be no missing values. Indeed, there are none. And here I'm going to compare the distributions from before imputation and after imputation using KNN. And here you see that it's far more like it, right? So you've affected much less the feature. So this is what I was trying to tell you. I hope that you enjoyed it. If you have more questions, please, I'll give you a bit more time to provide some questions. Okay. Uh, the the stream, like the video, is gonna be available in the channel. Next week we're gonna have again more broadcasts, provided that I already prepared the notebook for next week. So as I suggested, the best thing you could do is that go through Panda Zero for all the notebooks that are already there. If you're in English, there are like half of the notebooks are already there. If you're in Portuguese, you can look at all of them, and then come back here to Scikit Zero and see the first one. So we're then going to the data transformation notebook. So let me go back here just to show. Okay, through here it's going to be a bit tricky. So let me open again. Let me see Scikit Zero. So if I come here, the next one will be on data transformations, right? So about how to encode data, how to transform the data to fit it to a range, to center the data, to scale the variance, and to change the distributions, right? So here we did it with logarithm transformations. You're going to see a bit more elaborate techniques. So another question, let me see here. Is that any way to incorporate the standard deviation into the imputation so you don't impute only a single value? Let me see if I understand the question. So you're worried that you're not caring about the mean but about the standard deviation. Well, the standard deviation is basically, well, it's based on the variance, which is the average distance to the mean, but it's still a single value, right? So it's trying to capture the same thing as the mean. So the mean is the central point. The standard deviation is trying to encapsulate the spread of the data, but there's still a single value. I don't do it here. My optimization, my research field originally was multi-criteria optimization. So if you consider that you could use multiple criteria at the same time, it would be interesting to do that, having in mind at the same time the mean and the standard deviation. So you're talking about the centrality of the data and also about the spread of the data. But here I don't know how to do it. If there is a way and you figure it out, please let me know. But that's something I do not know how to indicate right now. Any more questions? In the meantime, I'd like to thank everybody for joining. And as I said, the videos will be available. If you're interested in some of these topics, I always recommend that you go to StatQuest. So this discussion here on mean and variance is very interesting that you see on StatQuest. I really like this channel. I really recommend it. Wait, instead of imputing only a single value, impute data that follows the same variance. I think you mean that you're going to impute multiple values at the same time, right? That would be interesting, but I haven't seen it. So that would be super interesting. That the accuracy would be that you have to predict all the points at the same time. But I mean, if you think about it, that's what KNN is doing, right? Because it's going to compute the accuracy based on all the outputs, all the predictions that it makes, like all the suggestions of values that it makes. And it's going to be fitting a model in that sense. So I would say that when you do the KNN imputer, in some sense, you're doing what you're saying. Do you agree, or did I understand wrong? Okay, so we're done for today. We've made it into 50 minutes, which is super nice, 50 something. Thank you very much for being here. As I said, this is a project that is meant to connect people in isolation because of COVID, and let's hope that everybody gets better. If you want to check a bit, so this is something I'm gonna post on Panda Zero later. If you want to check it, it's available at my GitHub pages. So right now I'm only doing this time series analysis stuff, and my goal is to also do that in terms of prediction. So if I let me copy this here to show you, and then I'll post the link here too on the chat. Okay. So the idea is that if you want to check data on the COVID, well, what's in Portuguese is something that is minimal in comparison to the graphics, where you can probably understand what's going on here. And unfortunately, when you see the data, you have the clear notion that within the next 3 days, so this is data from until yesterday, right? Right now, Italy has 80,000. I didn't check the US, but for sure the US has surpassed 70,000 because it's growing at over 10,000 a day. And Spain also grew at 10,000 a day. So we're gonna have serious competition between the US and Italy as still reaches 100k confirmed cases faster. Fortunately, the US is not having so many deaths in comparison to Italy. Although the correct approach would be to do this. So this is since the day where each country reported its 100th case, and here you can see that the US will not take very long to surpass Italy in terms of confirmed cases. In terms of number of deaths, it will take a little longer. So it's still like France, but trying to be more aggressive. Well, and also if you didn't notice that the country that is getting the worst situation in terms of confirmed cases in proportion to the size of their population is actually Switzerland, which is, but there's also an expectation that Spain will go even worse because at least Switzerland now has a trend that is quite stable, and Spain is still uprising. Anyway, these are some things that you can check, and I'll try to do some prediction here too in due time. Okay, thank you very much, guys. Enjoy, have a nice weekend. See you next week, and be tuned for the next broadcasts. Okay, see you.